Welcome students. In today's video, we are going to do a continuation of the previous two videos which have been uploaded on Python functions. This is found in chapter 7 in the Tamil Nadu Textbook Society. And this is the last video of that particular chapter. And we're going to start with built-in functions in Python. What are built-in functions? Another name for built-in function is called as a library function. And these functions are pre-written and preloaded into the interpreter of the Python. And you know that these functions are already loaded into the interpreter and we can use them as and when we want with the name of the function. There are many built-in functions available in Python, but in your textbook there are few of them which are listed out. So you will have a quick go through of these built-in functions which are there in your textbook. To start with, the first is called as the ABS function. Okay. The ABS function is called the absolute value function, which returns the absolute value of a number. Okay, the number can be an integer or a floating point number. What is absolute value? It gives you the modulus value of the number without the sign of the number. Now look at that syntax given there on screen, ABS of x, and the example for that is given. If x is 20 and y is 23.2, ABS of x and ABS of y will print out the value 20 and 23.2, neglecting the negative sign there. So this absolute value function is otherwise called as a modulus function, which gives you only the value without the sign. The second function that you're going to see here is called as the ORD function. This ORD function returns the ASCII value of the given Unicode character. Okay, so if you give a character in Unicode, a single character, it returns the ASCII equivalent of that particular character. Now the syntax is ORD of C, and if you see the example on screen, you have declared two variables C and D. C is equal to A, D is equal to capital letter A. When you print the ORD of C and ORD of D, the ASCII equivalent of C is 97 and the ASCII equivalent of the character D is 65. So you get the ASCII equivalent of the Unicode character that is enclosed within parentheses. In the next slide, we are going to see the CHR function, which is just the opposite of the ORD function. You know what it does? It returns the Unicode character for the given ASCII value. The ORD function returns the ASCII value of the Unicode character, but CHR function returns the Unicode character for the given ASCII value. If you see on screen, you can see the syntax is CHR of the variable. So if C is equal to 65 and D is equal to 43, this is the ASCII value for a certain character. So when you give the CHR within bracket C and CHR within bracket D, it gives the output as capital letter A and plus. That is, this is the Unicode character for the ASCII value of 65 and 43 respectively. So ORD function and CHR function are just the opposite of each other. Next comes bin function. See, this is a binary function which returns a binary string prefixed with 0b for a given integer. Instead of this bin function, you can also use format function, which we will be learning as we go further up. And what is the syntax of the bin function? Bin within bracket the variable. If you look at the example on screen, we have given x is equal to 15 and y is equal to 101. When you use this function bin of x and bin of y, it prints the binary value of x, which is 15, and the binary value of y, which is 101. And when the output comes on screen, you will find it is prefixed with this 0b, which indicates it's the binary equivalent of the given integer. So this is a very simple function and it is easy to understand. Next comes the type function in Python. You know what does this type function do? Type function actually has got 3 parameters and the type function has 1 parameter. We are not going to deal with 3 parameters because it is not there in your textbook. I'm going to teach you type function with just one object which is passed in as a parameter. You look at the this example on screen, you will find x is equal to 15.2 and y is equal to a, s is equal to 2. You know what does this type function do? It returns the type of the function or type of the object that you're passing through. That is, if you pass an integer, it will return a value as integer. If you pass a floating point value, it returns the answer as float. If you pass a string data, it returns a value as str, and if you pass a boolean value there, it returns a value as bool. If you look at that example on screen, x is 15.2, y is a, and s is equal to true. The first one, x is a floating point variable, so the output is float. The second one is a character. It's a single character or a single string, so it returns the value str. The third one is a boolean value because it is giving s is equal to true, so the output will be bool. So what does this type function do? It returns the type of the object that you're going to pass through as a parameter. Next is id function. The use of this id function is to give the address of the object in memory. See, you know that all variables that you are storing in the computer is in the memory, in some memory location under some memory address. We are not sure of what the memory address is, and we don't even know where the value is being stored in the memory. All that you know that each memory has a memory address. Suppose you want the memory address of the object that you're passing through, then we use this id function. And remember, this memory address differs from computer to computer, from system to system. It is not the same for all the system. But for that particular system where you're working on, and if you want the memory address of the variable that you're storing, then we use this id function. Look at that example on screen. X is equal to 15, y is equal to a. If you want the id of the variable 15, you give id of x, id of y. Output will give you the memory address of the particular variable 15 and the memory address of the particular variable a in the system that you're working with. So it is not the same in all the systems. It differs from machine to machine. The next that you're going to see on screen is three important functions: min, max, and sum. As the very word sounds, you know, min calculates the minimum value of the list, max calculates the maximum value of the list, and sum calculates the sum of the values in the list. The list that you're going to talk about here is something which you have not learned so far, and we'll be learning it in the other chapters. So remember that whenever you declare a list of values, you declare them in a square bracket. Can you look at that example on screen? My list is equal to 21, 76, 98, 23. Four values you have declared in the list, and the name of the list is my list. If you want the minimum value of the list, you say min of my list. Among these four values, 21 is the smallest value, so it will print the minimum of the list is 21. Same as max. Max is among the four values that you have declared in my list, the maximum value of the list is taken and printed out. If you want the sum of the values, it adds up all the four values declared in the my list variable, and it will print the total value of the my list as sum of my list equal to 218. So this is a very easy built-in function in Python. Next comes your format function. I told you this format function can be used in place of bin function also, but format is a little more elaborate than the bin function. You know what does this format function do? It will print the output in either in binary format, octal format, fixed point variable, or as a hexadecimal variable or a decimal variable, converting the given value integer to either binary or octal or any number system that you want to. Now look at that example on screen. X is equal to 14 and y is equal to 25. Format of x comma b. That means you're going to convert the value of x into binary. So it says b. Second one, you're going to convert the value of y into octal number. So it says o. The third one, you want the value in floating point or in fixed point notation, and remember that the default precision of this floating point variable or the fixed point variable is 6. That means you want 6 decimal digits after the decimal point. That is, by default the precision of that is 6, so it will print 6 decimal digits after the decimal point. Now you know, if you give the format within bracket two parameters, first is the variable comma the format of which particular number system that you want to. If you say B, it converts to binary. If you say O, it converts to octal. If you say H, it converts to hexadecimal. And if you say F, it will convert the value into fixed point notation or floating point notation. And remember that it gives you a precision up to 6 decimal digits after the decimal point. The next that you're going to learn in Python is round function. You know, this round function, what does it do? It rounds up the value to the nearest integer. And this round function is very useful to convert the given value to the nearest integer. So if you see on screen the example there, you have x is equal to 17.9, y is equal to 22.2, and z is equal to minus 18.3. Round of x, round of y, round of z. X will give the value 18 because it is rounding 17.9 to 18. Y will be printed as 22 because 22.2 is less than 0.5, so it will round it up to 22, and minus 18.3 will round it up to minus 18. The second type of this round function is you have two arguments there. The previous round function had only one argument. You just pass the value as an object. It gives you the rounded value of the object that you're passing through. But the second type of this round function has two arguments. The first argument is the number that you want to round, comma, the number of decimal digits desired after rounding. How many decimal digits you want after rounding? That's the second parameter. First parameter is the number that you want to pass through. The second parameter is the number of decimal digits that you want after rounding up the value. Now look at this again, that example on screen. If you see n1 is equal to 17.89, and when you pass that 17.89, for the first print it says n1 comma 0. That means you don't want any decimal digit after the decimal point, so it prints 18.0. The second one, n1 comma 1, you want only one decimal digit, so it prints 17.9 because it rounds out 17.89 to 17.9. The third print statement says n1 comma 2. You want two decimal digits after the decimal point. So when you want to round this up, it prints it at 17.89. So this round function has got two parameters. You can pass just one parameter and just get the value rounded up, or you can pass two parameters and get the number of decimal digits as you desire. The next mathematical function that we are going to learn is power. Normally when you want to represent to the power of, we use double star, two asterisks we use. Suppose I want to say 2 to the power 3, I say 2 double star 3, which means you are finding the power of 2 to the power of 3. Now look at this example on screen. It says A is equal to 5, B is equal to 2, C is equal to 3.0. So the print statement, print power of A comma B, power of A comma C, power of A plus B comma 3. So when it evaluates this, it finds the power of A comma B is 5 to the power 2, so it will print the value as 25. A comma C is 5 to the power 3.0, it will print the output as 125.0. The next one is A plus B to the power of 3. So 5 plus 2 is 7. 7 to the power of 3 will be 343. So this power is a very powerful mathematical function which helps you to find the power of the value given. Instead of using a double star, we use this function called POW. Next, I am going to show you how to use the different types of mathematical functions in Python. Mathematical functions are very important functions. There are many functions available in Python, but only 3 of them that is given in your book. We are going to look through it. And remember that whenever you are using a mathematical function, we have to import the math module before we start using it in a program. So before you start writing the program, we have to use import math, which means these mathematical modules which are stored in the Python interpreter will be opened up for use. And if you don't import this math module, we cannot use these mathematical functions in the program. And as you know, as I told you, there are many mathematical functions, but the three important mathematical functions listed in your textbook is floor, ceil, and sqrt. Floor is one mathematical function that helps you to find the largest integer less than or equal to the given value. You know what does floor do? Finds the largest integer less than or equal to the given value. You all know what is floor. Floor is the bottom or the base where you stand, and ceil is your top or the top or the portion of the house is called as the ceiling. So floor will give you the largest integer less than or equal to x, and ceil will give you the smallest integer greater than or equal to x. You have to remember this very carefully because floor and ceil are just the opposite of each other. Floor, remember, it is at the lower level, it is the base level, and ceil is the top level. Now look at that example on screen. Whenever you want to make use of this floor function, you must say math.floor within bracket the parameter. X is 26.7, y is equal to minus 26.7, z is equal to minus 23.2. Now when you use math.floor of x, math.floor of y, math.floor of z, the output will be as follows. If you take the first value x, 26.7, which is the largest integer less than x, that is 26. Now if you say minus 26.7, the largest integer less than minus 26.7 is minus 27. And if you take the third one, minus 23.2, the largest integer less than the value of z is minus 24. Now look at ceil. Ceil also works in the same manner. We use it as math.ceil with the parameter there. But ceil returns the smallest integer, not the largest, the smallest integer greater than or equal to x. Now look at that example. X is 26.7, y is minus 26.7, and z is minus 23.2. If you use it along with the ceil function, it will give an output as the smallest integer greater than x. So which is greater than x? 27. Minus 26.7, which is greater than that? Minus 26. Minus 23.2, which is greater than that? It is minus 23. So if you look at it carefully and understand it properly, you will know that they are just the opposite of each other and easy to remember. Next comes the sqrt function, which helps you to find the square root of the given value, and we incorporate that sqrt function along with the math keyword, right? Then the next topic that I'm going to talk about is composition in functions. You know what is composition? Suppose I have a function and it is returning a value, and if that return value becomes an argument for the next function, then we call it as composition. Just listen to what I'm saying. If there is a function and if this function returns a value and that value becomes an argument for another function in a nested manner, then we call that as composition. And compositions, we've been using it quite often in our programs. Whenever we're using an input function, we use this input function along with the int function to convert the string integer into an integer. Okay, so the output of this input function becomes an argument for the int function that we're going to use. Now look at the example that is given there. If you wish to take a numeric value or an expression as an input from the user, we take it in form of a string. To convert the string into an integer, we use an int function or eval function. Int function is used to convert one value, but eval function is used to convert an expression, evaluate an expression. Okay, now look at the slide which comes following this. It's an example of composition in function. You can see the first hash symbol indicates it's a comment line statement. The second is you've given an input statement, enter a number. Along with that input statement, we have used an eval function there, which means this output of this input statement becomes an argument for the eval function. So it gives the output as 234. If you input 234, it gives an output as 234. But if you input an expression, the expression is evaluated and the resultant of the expression becomes the argument for the eval function. So if you enter an expression 12.0 plus 13.0 into 2, according to the BODMAS rule, multiplication takes the first priority. So 13.0 into 2 is 26. You add 26 with 12, you get the output as 38.0. So here is an expression that is given into the input function. The resultant of that expression becomes the argument for the eval function, and then it gives the output. So what is composition in functions? The value returned by a function becomes an argument for some other function in a nested manner, and that is called as composition in functions. The next that I'm going to teach you is the last type of function in Python, that is a recursive function. Though it is the last function, is very important and widely used in a lot of places. Recursive function is nothing but when a function calls itself many times, it's called as recursion. Recursive function is very similar to loops, but there is a difference between loop and recursion, and you will know that recursive function is more flexible, more advanced, and can be used in many places than the loop function. And both of them have an iteration that takes place, but remember that the recursive function comes along with the condition, and that condition is called base condition. The condition must be there to finish the iteration, otherwise it will become an infinite iteration, it will become an infinite loop, and it keeps on be recursing again and again without a end. So remember that the recursive function should come in conjunction with the condition, and that condition is called as the base condition. If you look at the points that I've given on screen, when a function calls itself, it's called as recursion, and recursion is just like a loop, but it is more advanced and better in certain places when used. The condition that is applied in a recursive function is called the base condition, and remember that base condition should be there to put an end to the recursion, otherwise it becomes an infinite loop. The next slide I'm going to talk about what are the important points of recursive function and how it works. Recursive function is called only by an external code. It is just like a function because there will be a calling statement that calls for this recursive function. The second point is if the base condition is met, then the program gives a meaningful output and it will end the program if there is a base condition. If the base condition is missing, then the recursive function keeps on looping back and forth without an end, and it becomes an infinite loop. So we should have a base condition to put an end to this recursive function. This next slide we are going to see an example of a recursive function called fact. The name of the function is fact. If you see, the first line gives you the function definition statement, def fact of n. N is the variable that you're passing. Then it says if n is equal to 0, return 1. If otherwise, you keep on be using this fact of n minus 1, then again fact of n minus 1, then again fact of n minus 1, keep multiplying it to give the final product. So if you see in the print statement, you're passing 0 there, fact of 0. So if the value of n is equal to 0, you're going to return the output as 1. The second print statement you have given fact of 5, which means you're going to find the factorial value of 5. So what happens in this case? It multiplies 5 into 4 into 3 into 2 into 1 and gives the output as 120. This is a typical example of a recursive function that is used to calculate the factorial of a number. With this, we come to the end of this chapter 7, that is Python functions. It is given to you in 3 videos. I want all of you to go through all the 3 videos to know the complete chapter. Thanks for watching, boys, and I want you to go through all the 3 videos together. Thank you.